Hello, I'm Ed Murphy with the Astronomy Department at the University of Virginia, and this is Astronomy 3450, Mission to Mars, Lecture 1, The First Lunar Landing, Part 2. In our last lecture, I left off just before the landing on the surface of the moon. I had said that about 100 hours into the mission, the lunar module undocked from the command and service modules. The lunar module was named Eagle, and the command and service modules were named Columbia. Just after undocking, the lunar module spun itself around so that Michael Collins, the only astronaut left on the command module, could look back at the lunar module, which contained Neil Armstrong and Buzz Aldrin. And he could make sure that everything looked fine, that the landing legs had deployed, that the landing probes had deployed properly, and that the lunar module looked to be in good shape. And it did. And at that point, the lunar module separated itself from the command and service module and fired the descent engine on the bottom of the descent stage of the lunar module to bring itself down to the surface. Now, I've debated how to describe what the lunar landing was like, and I think ultimately the best way to do it is to actually play it for you in real time. And my favorite depiction of this, and depiction maybe is the wrong word, but my favorite recording of this actually comes from a series by the BBC called 13 Minutes to the Moon. If you haven't seen this podcast, it's a series of episodes about the first lunar landing. It was recorded, of course, for the 50th anniversary of the first lunar landing in 2019. It's a fantastic podcast series. I highly recommend that you listen to 13 Minutes to the Moon. But the 11th episode of that, they play nothing but the 13 minutes that they went from orbit down to the surface. And I think it's worth playing it just as it happened in 1969. Now, the thing is, you can find lots of videos on the internet where they take this recording and they synchronize it with the 16 millimeter camera footage. There was a 16 millimeter camera on board the lunar module that was, we would say today, videotaping, but of course then it was filming the descent as they went down to the surface. There were tape recorders that were running in mission control that were recording what all the controllers were saying. There are television broadcasts with Walter Cronkite and other famous television broadcasters talking about what's going on. But ultimately, to me, the most powerful recording of the landing itself is this one, which is basically just the air-to-ground loop. And that is the loop that Charlie Duke heard. Charlie Duke was the Capcom. Charlie Duke is an astronaut, Apollo astronaut. He would later fly on the Apollo 16 mission to the moon. But when the astronauts in orbit talk to the Earth, they talk through somebody called the capsule communicator, or the Capcom. And it is usually another astronaut. And in this particular case, for the first lunar landing, the Capcom was Charlie Duke. And that's because he knew more about the lunar module than any other astronaut that wasn't in space at that moment in time. And Neil Armstrong wanted him specifically to be the Capcom because he knew if they came up with any problems during the landing, that Charlie Duke was as equipped as anybody on Earth to help them figure out what was wrong. So what we're going to hear is what Charlie Duke heard in his headphones. That is his communications with Neil Armstrong and Buzz Aldrin on the Eagle as it descends down to the surface, and also what he heard from the main control loop talking to Gene Kranz, who was the primary flight controller, the chief flight controller, as they went down to the surface. The other thing that's worth pointing out is that other than this audio communication and the data that was coming down from the spacecraft, they didn't have any live video. So as I play this recording of the first lunar landing, I'm also going to show you a blank screen because this was part of the tension in those days. They didn't have a live video broadcast to see what was going on. All they heard were what the astronauts were telling them. That film camera that was running, of course, that film wouldn't be developed until long after the mission had landed. Now, before I begin the recording, I do want you to let you know of a couple things that you should listen for in the landing. So a couple things that I want you to listen for is the landing did not go very smoothly. And the first thing to remember about the landing is you and I know what's about to happen. And in fact, we know how it turns out. We know that it's successful. We know that they survive the landing. They have a successful mission. They come home. We even know now that the astronauts, these three astronauts, Neil Armstrong, Michael Collins, and Buzz Aldrin, live long lives after the Apollo mission. That wasn't true at this moment in time. In fact, most of the astronauts felt that there was about a 50-50 chance that the landing would end in failure. And they believed that there was about a 1/3 chance that the astronauts would actually die while trying. There were a lot of dangerous things that went on during the descent. For example, aborting the descent to try and come back up if something went wrong was known to be exceptionally dangerous. They believed there was a very good chance the astronauts would die doing this, and that there was only a 50% chance that they would succeed. So it's easy for us knowing that it's going to be a success, but you have to realize at the time that they were under a tremendous amount of tension. And on top of that, the landing didn't go smoothly. In the recording that I'm about to play you, I want you to listen for what happens right away. Almost immediately as this recording begins, they're having communications dropouts with Eagle. As they're trying to communicate with Eagle from the Earth, they tell it to yaw 10 degrees in order to try and improve the communications. That doesn't really help. You'll hear a long period of static where they couldn't communicate with the spacecraft at all. A few minutes later, you will hear one of the controllers say that they're negative misfin. Misfin was the Manned Spaceflight Center network. That was the network where they got data from the spacecraft. That had gone down, and they were no longer getting data from the spacecraft. The controllers are trying to make a decision whether they should allow the landing to proceed or not, and their data is dropping out. At the same time, in orbit around the moon, Neil Armstrong is looking at landmarks as they pass below Eagle. And he notices that these landmarks are coming about 2 seconds earlier than they should, which means that Eagle is overshooting its landing. And he also realizes that the computer doesn't know this. On top of all of this tension, some alarms start going off in the cockpit. The first one is a 12:02 alarm, and you will hear the astronauts announce 12:02 alarm. This alarm meant that something was seriously wrong with the computer on the lunar lander. Mission Control has to figure out what this alarm is. The astronauts don't have time to look it up. They're busy flying the spacecraft down to the surface of the moon. And Neil Armstrong gets frustrated with Mission Control, and he says, I want a readout on that 12:02. And you'll hear them come back to him and say, your go. It turns out, as we'll learn later in the semester, and as you will see in reading A Man on the Moon, that fortunately, in one of the training sessions a few months before the lunar landing, the mission controllers who were training for this, there was a set of training controllers, and they threw in an alarm just like this. And normally when these alarms go off, they had a large book that they would look through to determine whether the alarm was serious or not, whether they could proceed with the landing or whether they had to abort the landing. This type of alarm, which meant the computer was too busy, was one that they didn't normally deal with. And they had only seen it that one time in practice. But fortunately, during the landing, when the 12:02 alarm went off, the controllers recognized it, that it just meant the computer was busy and that the landing could proceed. The alarm goes off a number of other times during the landing. A similar alarm, a 12:01 alarm, goes off later on. As Armstrong gets the spacecraft close to the surface, he sees that the computer is bringing him down on a large crater that's surrounded by a boulder field. And he realizes he has no choice but to take over and fly manually to fly over that crater and go even further downrange than he already was. At this point, the controllers realize that Neil Armstrong's in charge, and that although he's certainly listening to what they say, he's making all the decisions at this point. And so Charlie Duke says to Gene Kranz that I think we'd better be quiet. We should just let Neil fly. And Gene Kranz says the only thing he wants to hear at this point are fuel callouts, how much fuel is left. As Neil Armstrong flies the spacecraft looking for a landing site, he sees areas that are covered in boulders. He sees areas with craters. He finally selects a nice smooth area where he's going to land. Now, he should have landed with about 2 minutes of fuel remaining, and at the very end of the recording, you will hear callouts for 60 seconds of fuel, 30 seconds of fuel remaining before they finally touch down on the surface. In all the simulations they had ever run, they never ran that short on fuel. And never again in all the Apollo missions would a landing come so close to disaster. It's estimated that when Apollo 11 set down on the surface of the moon, they had less than 20 seconds of fuel remaining in the tanks. It was a near disaster. Knowing all that, listen for that in this recording of 13 minutes as they descend down to the surface of the moon.
The audio recordings of the conversations between Mission Control and the Apollo 11 astronauts are instantly recognizable whenever you hear them. Unmistakable as anything else other than a crew hurtling towards the moon, being guided by their Mission Control team across the void of space. Those voices and sounds are so familiar and yet nearly impossible to decipher without a lot of help. But now you know exactly what you're hearing, here's a chance to listen again to history as it happened. I'm Kevin Fong from the BBC World Service. This is 13 Minutes to the Moon. There were many communication channels in Mission Control, and what you're about to hear is Capcom Charlie Duke's loop. This is the final 13 minutes of descent to the moon on July the 20th, 1969, exactly as he heard it that day. Episode 11, The 13 Minutes.
Mission 10%.
10% CCP.
Raj, 10%.
Turn on, we have 20 foot per second residual. That is probably due to downtrack error.
I'll leave it in blue. Relay to it.
20-foot residual due to downtrack
See if
error.
they got me now. I can get signal straight to blue lights.
You should have me now, Houston.
Eagle, we got you now. It's looking good, over.
Roger, GTC go.
Flight control, we're go. FTP looks good.
Roger. Eagle, that looks good.
Eagle, Houston, everything's looking good here, over.
Roger, copy.
Eagle, Houston, after yaw around angles, S-band pitch, -9er, yaw, +18.
Flight spotter, we have negative misspin.
Roger, negative misspin. You got that? Copy. Fido, what data do you have?
Pings and ags and Doppler flight, we
Roger.
go. Restarting misspin now.
Roger, how's the Doppler looking?
Looks good, flight.
Roger. Ags and things agree very closely.
Roger.
Dips thrust 9820.
Roger, thrust 9820.
Copy, flight.
Data 7. How are you looking, guidance?
Taking out 20 foot per second.
Altitude, go high. No change is what you're saying.
No change. That's downtrack, I know it.
Roger.
Flight Fido.
Go, Fido.
We've reinitialized the filter. We do have an altitude difference.
Roger.
Yeah. Go.
Flight Fido, GTC is
You're
right on
getting a
normal.
little fluctuation in the AC voltage now.
Roger.
50 meter maybe, huh?
Stand by.
Okay.
It's looking good to us. You're still looking good at coming up 3 minutes.
Okay, control, let me know when he starts his yaw here.
Roger.
How's your misspin looking now, Fido?
Flight Fido, we do have the altitude. We're go.
Okay, how about you guys?
Hold that 18 foot. We're going to make it a position
Right.
can range to it to be a little long.
Roger, copy. I think you're a little bit long downrange.
That's right, I think we confirm that.
We confirm that.
Roger. Okay, all flight controllers, 30 seconds to next go, no go.
Show it to be about standby.
I'm going around the horn. Make your go-no-goes based on the data you had prior to LOS. I see we got it back. Another few seconds.
We're yawing fine.
Okay, retro.
Go.
Fido.
Go.
Guide.
Go.
Control. Go. Telcom. Go. GNC. Go. Econ. Surgeon. Go. Capcom. We're go to continue PDI.
Eagle, Houston, you're a go to continue.
Go at 4 minutes.
Did you get that Telcom?
You're a go to continue power descent. You're a go to continue power descent.
Okay, everybody, let's hang tight and look for landing radar.
Flight guidance.
Go, guys.
We got one
And Eagle, Houston, we got data dropouts. You're still looking good.
on the pings.
Roger, I copy guidance.
Okay.
Okay, we got data back.
Radar flight looks good.
Raj.
2,000 feet.
Raj, 2,000 foot Del H.
Good lock on.
Let me know when he accepts it, guidance.
Altitude lights out. LH is minus 2,900
Roger, we copy.
at the Earth, right out our front window. Houston, you're looking at our Delta H.
That's affirmative.
Program alarm.
Looks good.
It's looking good to us,
Is he
over.
accepting it, guidance?
1202. Standing by. 1202.
Looks like it's converging.
1202 alarm. Yeah, the same thing we had.
Flight, retro.
Go, retro.
Throttle down. 6 plus 2. Give us a reading on the 1202 program alarm. We're going
Roger.
that flight.
We're going that alarm?
Roger, we got you. We're going
if
that
it does
alarm.
reoccur, we'll be go. He's taking in a Delta H now.
Raj.
Roger. 330.
Did you get the
6
throttle
plus
down,
25, throttle
Right.
down.
That's,
6 plus
8,
25,
20.
throttle down.
Flight Fido converging on Delta H.
6
Right.
plus 25.
Flight control, we have velocity.
Raj.
Same alarm, and it appears to come up when we have a 1668 up.
Roger, copy.
Okay, we'll monitor his Delta H flight.
Raj.
I think that's what he's getting.
Okay.
Eagle, Houston, we'll monitor your Delta H.
And his alarms.
Raj.
Delta H is beautiful.
Delta H is
looks
looking
good now.
Roger, Delta H is looking good to us.
Okay, all flight controllers, hang tight. Should be throttling down pretty
Throttle
shortly.
on time.
Roger, copy, throttle down.
You confirm throttle down.
Better in the simulator.
Roger.
How's it looking, guys?
Bags and things look real close.
You want him to stay out of 68?
Negative flight. I just said we'll monitor the alarms.
Okay.
Okay.
Flight control,
Go.
everything looks good.
Flight
Raj.
guidance.
Go, guidance.
So now 68 now well may be the problem here, and we can monitor Delta H.
Raj.
Flight Fido looking
Go,
real
Fido.
good.
Raj, Fido, good.
At 7 minutes, you're looking great to us, Eagle.
Telcom, how you
Okay,
looking?
I'm still on
Good,
flu,
Raj.
so we may tend to lose as we gradually pitch over.
Let me try auto again now, see what happens.
Gonna try the steerable again, Dan. Copy.
Okay, looks like it's holding.
Roger, we got good data.
We on steerable, Dan?
That's a birdie flight, and it's holding in there pretty good.
Raj. Okay, everybody, hang tight. 7.5 minutes.
Flight guidance, landing radar is fixed. The velocity's beautiful.
Raj.
Flight control,
Go control.
2, fuel.
Descent 2, fuel crit.
Descent 2, fuel only. No
Fuel.
critical. He didn't want to say critical.
Raj. Descent 2, fuel.
Eagle Houston, is descent 2 fuel to monitor, over.
Down to 2. Flight Fido looking real good.
Raj.
Give us an estimated switchover time, please. You.
Roger, stand by. You're looking great at 8 minutes.
You got an estimated, what's our T-go guidance?
30 seconds to P64.
Raj, about 30
Eagle,
seconds.
you got 30 seconds to P64.
Okay, we still got landing radar guidance.
Affirm.
Okay, is it
Oh,
converged?
it's beautiful.
Is it converged?
Yes.
Okay.
Flight Fido, we're go. Look real good.
Raj, Fido.
Eagle Houston coming up 8:30. You're looking great.
P64.
Okay, they got
We
64.
copy.
T goes good.
Raj, T-goes go.
We have position 2 on the alarm.
Raj, position 2, all flight controllers, 20 seconds to go, no go for landing.
Eagle, you're looking great. Coming up 9 minutes.
Okay, all flight controllers, go, no go for landing. Retro.
Go.
Fido.
Go.
Guidance.
Go.
Control.
Manual
Telcom.
control is good.
GNC.
Go.
Ecom.
Roger, copy.
Surgeon.
Go.
Capcom, we're go for landing.
Eagle Houston, you're a go for landing, over.
Roger, understand. Go for landing. 3,000 feet. Program
Copy.
alarm. 1201. 1201.
Roger, 1201 alarm.
1201 alarm.
Same
guidance.
type, we're go flight.
Okay,
We're go. Same type, we're go.
Flight Fido right on. Real good.
Roger.
2,000 feet. Into the ag. 47 degrees.
Roger.
47 degrees.
How's our margin looking, Dodd?
It looks okay. We're
Okay.
about 4.5.
Roger.
Eagle looking great, you're go.
Altitude update in the eggs. Looks good.
Roger.
Roger, 1202, we copy it.
How you doing?
35
Control?
degrees. We look good here. Fine.
Roger,
35
how about you,
degrees.
Telcom? Go.
750.
Guidance, you happy?
Go.
Down to
Fido.
23.
Go.
700 feet, 21 down. 33 degrees. 100 feet down at 19. 540 feet down at 30 and at 15. Attitude hold.
Okay, at hold.
I think we better be quiet.
And 400
Roger.
feet down at 9.
Okay, the only call-outs from now on will be
Gate
fuel.
forward. 350 feet down at 4. 30 and a half down. They're pegged on horizontal velocity. 300 feet down, 3.5. 47 forward. Hold up. Down 1.5 down. 70. Got the shadow out there. 50 down at 2.5. 19 forward.
Okay, Bob, I'll be
Altitude,
standing by for your
velocity,
call-out
light.
shortly.
3.5 down. 220 feet. 13 forward. 11 forward, coming down nicely. 200 feet. 4.5 down. 5.5 down. 160 feet. 6.5 down. 5.5 down. 9 forward.
Low level? Low level.
Good. 120 feet. 100 feet, 3.5 down, 9 forward. 5%. 185. Okay, 75 feet. Car's looking good, down a half.
60. Roger.
6 forward.
60. 60 seconds.
60 seconds.
Lights on. 6. Down 2.5. Forward. feet down, 2.5. Picking up some dust. 30 feet, 2.5 down. Straight shadow. 4 forward. 4 forward, drift into the right a little.
30. 30 seconds.
30 seconds.
Forward, just. Good. Okay. Contact light. Okay, engine stop. APA at a descent. Mode control both auto, descent engine command override off. Engine arm off. 413 is in.
We've had shutdown.
We copy you down, Eagle.
Okay, everybody, T1. Stand by for T1.
Tranquility Base here. The Eagle has landed.
Thank you to NASA for the recording of space exploration's most extraordinary 13 minutes.
So I think it's really remarkable to listen to that and listen as you're listening to history happen as the Apollo 11 astronauts landed on the moon. So let's talk about what happened after they landed. It turns out immediately after landing, they had a lot of work to do because they weren't sure whether they could stay or not. If anything had gone wrong with the spacecraft systems, they may need to lift off right away. And so the first few minutes spent on the surface of the moon were making sure that the spacecraft was in good shape and that they could stay. Once it was clear that they could spend some time on the surface, they then began surface operations. And the first thing they wanted to do was grab a picture out the window. And this is the first ever picture taken by humans from the surface of another world. It's the lunar surface just after landing. In the foreground, you see one of the thrusters that was located on the lunar module. It was taken out Neil Armstrong's window, looking at the desolate lunar surface. Nearby, there was a small crater, a depression in the surface of the ground, in the surface of the moon. So the initial plan after landing on the surface of the moon had been that the astronauts would take about a 4-hour rest period. After all, they'd already had a long day. They woke up in orbit around the moon. They spent the morning preparing the spacecraft. They then landed down on the surface, and they had already been up for well over 12 hours. And the initial plan had called for a rest break before going out on the surface of the moon. But Neil Armstrong and Buzz Aldrin were too keyed up, and they realized that they weren't going to get any sleep. They weren't going to get any rest. And they asked, with Mission Control's permission, to go ahead and get ready and do the EVA, to go outside as soon as possible. And Mission Control gave them permission. Interestingly, Neil Armstrong felt that the most important part of the mission, the hardest part of the mission, was actually landing on the surface of the moon. But he also understood that for most people, they recognize the first step on the surface of the moon as being significant. But again, he thought that as a pilot, that the landing was the much harder thing to do. After all, once you were on the surface, going outside just meant putting your spacesuit on, climbing out the hatch, going down the ladder, and stepping on the ground. That the ladder was where all the difficulty really was. So let's go ahead and watch a video of the first step on the surface of the moon.
Did you get the main down? I'm going to pull it now. Houston, the Mesa came down. All right.
So the first thing, as Armstrong was coming out of the lunar module, he released the Mesa, which was an equipment carrier that had mounted on the end of it a video camera that he would use so that people on Earth could watch him descend the ladder down to the surface.
Houston, this Neil, radio check. Neil, this is Houston, loud and clear. Break, break. Buzz, this is Houston. Radio check and verify TV circuit breaker in.
Roger, TV circuit breaker's in. Read 5 clear.
Roger. And we're getting a picture on the TV.
TV. Okay. You got a good picture, huh?
There's a great deal of contrast in it, and currently it's upside down on our monitor, but we can make out a fair amount of detail.
Okay, would you verify the position, the opening I ought to have on the camera?
Stand by. Okay, Neil, we can see you coming down the ladder now. Neil, we can see you coming.
Okay, I just checked, getting back up to that first step. That isn't collapsed too far, but it's adequate to get back up.
Roger, we copy.
It's a pretty good little jump.
Buzz, this is Houston. F2, 1/160th second for shadow photography on the sequence camera.
Okay. At the foot of the ladder, the LEM footbeds are only depressed in the surface about 1 or 2 inches, although the surface appears to be very, very fine-grained as you get close to it. It's almost like a powder. Ground mass is very fine. I'm going to step off the LEM now. That's one small step for man, one giant leap for mankind.
Now, immediately after taking that first step, Armstrong had jobs that he needed to accomplish. One of the first ones was to photograph the surface, and this is the first image that Neil Armstrong took from the surface of the moon. We can see one of the lunar module legs there. We can see the landing probe that used to stick down underneath the leg has actually bent backwards and bent upwards by the landing. That's okay. That was expected to happen. We see on the surface down here a jettison bag. This was literally a bag of garbage that the astronauts had accumulated inside the spacecraft before going out on the surface of the moon. They put it all inside that bag, and as they were going out on the first walk, they had pushed it out on the surface. And then you see off in the distance, of course, the lunar surface. Now, this first moonwalk was meant to be about 2 hours long. They had a lot of work they had to get done in that time. Now, they had practiced this moonwalk over and over again, and they had it mostly memorized, but just to make sure they carried checklists with them. In this particular case, for Apollo 11, the checklist was actually sewn into the cuff of each of the astronauts' arms. So this is the glove that Neil Armstrong was wearing on the surface of the moon, and you can see that there's a sewn patch on that glove, and it has step by step each of the things that they need to do on the surface of the moon, starting at the very beginning with the camera deployment to the very end when they load the materials back on the lunar module. The things that the commander does is written here. The things that the lunar module pilot does are in parentheses on the side. The lunar module pilot had his own checklist that he was following along as well. Now, one of the first things that he had to do was grab a contingency sample. A contingency sample is an emergency sample that's taken right away in case they have to leave in an emergency, and they wouldn't want to leave the surface of the moon without taking at least some samples with them. So in this video, you'll see Neil Armstrong. He's filmed from a camera that's mounted in one of the windows of the lunar module, assembling the tool that he's going to use to scoop up the soil, and then scooping the soil up and scooping up some rocks as well.
Okay, the contingency sample is down and it's up sample. Like it's a little difficult to dig through the initial crust. Very interesting. It's a very soft surface, but here and there where I plug with the contingency sample collector, I run into very hard surface, but it appears to be very cohesive material of the same sort. I'll try to get a rock in here. Just a couple. Oh, that looks beautiful from here, Neil. It has a stark beauty all its own.
After obtaining the contingency sample, the next thing that happened is that Buzz Aldrin, the lunar module pilot, came out of the lunar module Eagle. So this is a series of photographs that were taken by Neil Armstrong of Buzz Aldrin as he left the lunar module. I think it's a really nice example of what it took to leave the lunar module. First thing you'll notice, the astronauts are, of course, wearing the bulky spacesuits. They've got the life support system that they're wearing on their back that contains all their oxygen, the cooling water, everything that they need to keep the batteries, everything they need to keep themselves alive. In order to get out of the little square hatch on the lunar module, they had to get down on all fours, and they had to crawl out backwards onto this little device that they call the porch that was just outside the door. Once on the porch, they could get on the ladder, and then once they were on the ladder, they could lower themselves slowly down to the surface, and then there was a long jump from the last rung on the ladder to the landing pad. And then you see Buzz Aldrin there ending up down on the landing pad, down on the surface. Shortly after Buzz Aldrin came out, Aldrin and Armstrong together read a plaque that was on the side of the lunar module, the landing strut that was there, and here's the reading of that plaque.
Neil is now unveiling the plaque that is. Roger, we got you bore-sighted, but back to one side. Bore-sighted. For those who haven't read the plaque, we'll read the plaque that's on the front landing gear of this LEM. There's two hemispheres, one showing each of the two hemispheres of Earth. Underneath it says, "Dear men from the planet Earth, first set foot upon the moon, July 1969 AD. It came in peace for all mankind." It has the crew members' signatures and the signature of the President of the United States.
So here's the plaque that is mounted on the landing leg of the lunar module Eagle. Shortly after that, they then began setting up scientific experiments. Buzz Aldrin had to deploy something called the solar wind collector. It's essentially a piece of aluminum foil stretched between two poles, and wind from the sun would come and impinge on this foil. And at the end of their spacewalk, at the end of their time outside, they would roll up that that foil. They would pack it back inside the spacecraft, bring it back to Earth. And once it was back on Earth, scientists could take the particles from the sun, the solar wind that were embedded in that foil, and pull them out of the foil and analyze them. It was debated early on as to whether they should plant a flag on the moon, and it was decided that they would. And so they planted the U.S. flag on the surface of the moon. This is a picture of Buzz Aldrin saluting the flag. Couple of things you'll notice about the flag. First of all, you'll notice that because there's no atmosphere on the moon and there's no wind to blow the flag, in order to keep it out, they had to suspend a metal bar across the top right there. So in addition to the flag pole, there is a metal bar that is sewn into the top of the flag, and they lifted that metal bar out and secured it so that the flag would be held horizontally. It looks like the flag is waving here, and it is not waving in a breeze. What you're seeing there are just creases and folds in the flag from when it had been tightly wrapped up in the container that was used to launch it. Shortly after this, the astronauts received a call from President Nixon. And so let's listen to that.
This is Houston. Can we get both of you on the camera for a minute, please?
Say again, Houston.
Roger, we'd like to get both of you in the field of view of the camera for a minute. Neil and Buzz, the President of the United States is in his office now and would like to say a few words to you. Over.
That would be an honor.
Go ahead, Mr. President. This is Houston out.
Hello, Neil and Buzz. I'm talking to you by telephone from the Oval Room at the White House. And this certainly has to be the most historic telephone call ever made. I just can't tell you how proud we all are of what you... For every American, this has to be the proudest day of our lives. And for people all over the world, I am sure they too join with America in recognizing what an immense feat this is. Because of what you have done, the heavens have become a part of man's world. And as you talk to us from the Sea of Tranquility, it inspires us to redouble our efforts to bring peace and tranquility to Earth. For one priceless moment in the whole history of man, all the people on this earth are truly one. One in their pride in what you have done, and one in our prayers that you will return safely to Earth.
Thank you, Mr. President. It's a great honor and privilege for us to be here representing not only the United States, but men of peace of all nations, and with interest and a curiosity and with the vision for the future. Honor for us to be able to participate here today.
And thank you very much, and I look forward, all of us look forward to seeing you on the Hornet on Thursday. Look forward to that very much, sir.
So this is probably one of the more famous images taken by the Apollo 11 mission, which is actually Buzz Aldrin's boot print in the surface of the moon. It's often depicted as the first step on the moon, but we don't actually have a picture of Neil Armstrong's first step on the moon, and that's because he was testing the surface of the moon, so he was dragging his foot to see how thick the soil was, how dense the soil was, and actually ended up destroying his own first footprint. This was one that Buzz Aldrin actually made specifically so that scientists could look at how the soil held together after the boot print. And that is one of the more famous images that came out of the Apollo 11 mission. So these are just a couple fantastic images. I love this one in particular because this is the only good picture of Neil Armstrong on the surface of the moon. Now, there was only one camera that they had down on the surface with them. It was a Hasselblad camera, a very, very fancy, very, very high quality camera. And the instructions indicated that at various times the two astronauts were to pass the camera back from one to the other, and they were to photograph certain things. And just the way that the schedule was set up, it turns out that Neil Armstrong was scheduled to take most of the photographs and did take most of the photographs. And when Buzz Aldrin had the camera, he spent his time photographing the things he was supposed to photograph. And it turns out, I guess in hindsight, when we look back at the mission, the one thing that's lacking is a really good photograph of Neil Armstrong on the surface of the moon. Almost all the photographs that you see are photographs of Buzz Aldrin taken by Neil Armstrong. And probably the most famous photograph to come out of the Apollo program is this photograph of Buzz Aldrin standing on the surface of the moon. So here's Buzz Aldrin, and if you look in the reflection of his visor, you can actually see Neil Armstrong and the lunar module reflected in his visor. Normally you see this, it's cropped a little bit differently. They crop out the dirt in front of the astronaut, in front of Aldrin right there. They crop out the lunar landing pad and the bent landing probe right there. So they'll usually crop it right below his feet, and they'll usually add a little bit of black sky behind it to stretch the top of the image. So you've almost certainly seen this image before, but just cropped a little bit differently. This, I'm showing you here, the actual uncropped image. Standing on the surface of the moon, when you look back up at the Earth goes through its phases, just like the moon goes through its phases. The moon takes about a month to go through its phases, and standing on the surface of the moon, the Earth takes about a month to go through its phases. So this is a picture that was taken looking up at the Earth with the lunar module in the foreground. You can see some of the reaction control system thrusters here on either side, a couple of the antennas that were used to communicate, and one of the landing struts that's coming down towards us right there. One of the primary goals that they had while down on the surface was to deploy scientific experiments, two main scientific experiments on the surface of the moon. Here we see Neil Armstrong photographing Buzz Aldrin. So sorry, this is Buzz Aldrin at the lunar module right there. Packed into the descent stage were two scientific experiments. One was a passive seismometer that would be placed down on the surface that would measure seismic waves in the moon, and that would allow scientists to determine what the inside of the moon was like. And then the other experiment that was laid out was a lunar laser retroreflector, and this was essentially prisms that would take laser light from the Earth and reflect the laser light right back again. And scientists on the Earth could use powerful lasers, bounce them off the moon, and determine the distance from the Earth to the moon to within a few centimeters. And those lunar laser retroreflectors that are still on the surface of the moon are still used by astronomers today to measure the distance to the moon precisely. So here are just a couple of other pictures of the surface. What we see are some rocks on the surface. You see that the surface of the moon is covered in craters, everything from small craters to large craters that are hit as meteorites and comets and asteroids. In this case, small meteoroids strike the surface of the moon. The thing is, when you look at this surface of the moon, you are looking at a surface that is billions of years old. This part of the moon hasn't had anything significant other than small meteoroid impacts happen for billions of years. And that is one of the reasons that the moon was so interesting to scientists, is the moon is a fossil of the early solar system. It tells us what was going on in the early history of the solar system. Here we see Buzz Aldrin carrying the lunar laser retroreflector and the seismometer off to the station to set them up. There's the seismometer set up, so it was solar powered. There's the antenna pointing back towards the Earth so that we could get the signals back from the seismometer. The seismometer continued to operate for a couple of weeks after the astronauts left the surface of the moon. Other seismometers that were left by other missions ended up operating for years on the surface of the moon. And the lunar laser retroreflector is a passive experiment. That is, it doesn't require power or anything, so we can still bounce lasers off that today. Right after Armstrong and Aldrin set up these scientific experiments, Aldrin went back to the lunar module to carry out a couple of other tasks. One of the tasks was to photograph the lunar module very carefully. That would be used to determine what damage, if any, was done to the lander when they landed so that they could make modifications for future missions. Neil Armstrong realized that he had a few minutes in the timeline, and so Neil Armstrong actually wandered off to a nearby crater. He wandered about 200 feet, about 60 meters, to a crater that is now called Little West Crater. The crater itself was about 100 feet in diameter, and you see the photograph that Neil Armstrong took looking down into the bottom of the crater. One of the things that you notice here is because there's no atmosphere on the moon, shadows are incredibly dark. Anything in the shadow of a crater is almost invisible. On Earth, that would be lit up by light scattered by our atmosphere. But on the moon, with no atmosphere to scatter light, those shadows are incredibly dark. Just after taking this photograph, Armstrong turned around and he photographed the lunar module sitting on the surface. And this is as far as the astronauts wandered from the lunar module during the Apollo 11 mission. As I said, he's about 200 feet away from the lunar module. In future missions, they would bring rovers to the surface and they would drive miles across the surface of the moon. But in the case of Apollo 11, the goal was to land on the moon, return safely to Earth, deploy a couple experiments, bring some samples back, and do it as quickly and safely as possible. And so the astronauts did not wander very far from the lunar module. When Armstrong returned back to the lunar module, he found Aldrin in the process of driving a core tube into the ground. This is a hollow tube, and scientists believe that the surface here, the regolith, the soil on the surface of the moon, would have many different layers in it, and that these layers would have been laid down over time. And this was a hollow tube that they were to drive as deep into the surface as they could that would capture all of those layers. In the end, he was supposed to drive it as deep as he could. He could only actually drive in about 8 inches before the compaction of the soil stopped it from going in further. After a little less than 2 hours on the surface, it was time to wrap up. Buzz Aldrin returned to the lunar module first, and then Neil Armstrong packed some rocks in some boxes. There were a number of samples that Neil Armstrong was supposed to take. The first was that contingency sample, that first one he grabbed. The second one was a set of rocks where he tried to pick as wide a variety as he could. And the third sample that Neil was supposed to take was called a documented sample. It was where he was supposed to photograph the rocks on the surface with instruments to show scientists exactly where and how they were located on the surface, where the sunlight was striking them so they could determine their orientation on the surface of the moon. And this was called a documented sample. In the end, Armstrong didn't have time to document his samples as well as the scientists would have liked. So those heavily documented samples had to wait to the next mission to the moon, Apollo 12. But Neil packed all of the rocks in a couple of aluminum boxes that were special built for the purpose. And then when the rocks were in the box, he noticed that there was extra room and he ended up shoveling some of this regolith. We would call it dirt on Earth, but it's formally by scientists called regolith, this soil on the surface of the moon. He scooped a bunch of that into the boxes just to finish filling the boxes. And it turns out that afterthought turned out to be one of the most useful things, one of the better things that he happened to think of off the top of his head to do, because that sample has turned out to be incredibly useful for learning both about the history of the moon and in studies of the lunar rocks. So after a little bit less than 2 hours, the EVA was over and both astronauts returned to the interior of the spacecraft. And this is a picture of Neil Armstrong inside the lunar module Eagle, just after the completion of the extravehicular activity, just after the spacewalk. You can see behind him there a panel of circuit breakers, and they've taped using duct tape. Gray tape is it's sometimes called, where they taped a placard up there showing them what each of the circuit breakers did. But that's Armstrong in the lunar module just after coming back inside. They had now been up for 24 hours continuously without a break, and so it was time to take a rest. And so Armstrong and Aldrin attempted to go to sleep. They did not have hammocks or any good way to sleep, so Armstrong sat on the ascent engine cover, and Aldrin laid on the floor as best they could. Neither of them could really get any sleep, but they did try to take a few hours to grab some rest before they had to lift off of the surface of the moon. Finally, when it came time to lift off the surface of the moon, they fired the engine on the ascent module, and that ascent module brought the lunar module Eagle into orbit. They spent a few hours in orbit around the moon, matching their orbit to the command module, and then Michael Collins in the command module docked with the lunar module. They took their suits and all of their samples from the lunar module, moved them over to the command module, and then the lunar module itself was discarded. It ended up remaining in orbit around the moon for many months and eventually crashed down to the surface of the moon after months in orbit. Once they were back on the command module, they then spent another day in orbit around the moon and then fired that giant SPS engine on the bottom of the service module to head back to Earth. It took a couple days to get back to Earth. Once they got back to Earth, they discarded the service module and they used the heat shield on the command module to come down to the surface. And here they are being picked up in the Pacific Ocean. Now, because this was the first mission that landed on an extraterrestrial planet, there was some concern that there could be microbes or organisms living on the surface of the moon. And what if the astronauts picked up those microbes or those organisms and brought them back to Earth? There was some fear that those microorganisms could contaminate the Earth. And catastrophists, people who were worried about a catastrophe, worried, what if, because we hadn't been exposed to these organisms before, what if our immune systems couldn't do anything about them? So to try and limit the possibility, so first of all, most scientists believe that this wasn't really possible. The surface of the moon is in a hard vacuum. It's exposed to the ultraviolet light from the sun. No organism on Earth could survive the punishing ultraviolet light and the vacuum for billions of years and survive for that long to be brought back to Earth. But nevertheless, to reduce the possibility, when the astronauts landed, a Navy diver opened the hatch and threw into them these isolation suits that they put on immediately. And then the diver helping them put on one of the suits as well. After the suits were on, the astronauts climbed out of the command module, got into this raft, and they waited for a helicopter to come pick them up. Once the helicopter picked them up and they landed on the USS Hornet, which was an aircraft carrier, they were immediately shuttled into an isolation van. This was a small van that had been converted into a biological isolation unit, where they would spend the next about 20 days in isolation, making sure that no one came down with any diseases that they had brought back from the moon. President Nixon flew out to greet them. So here they are on the USS Hornet in that isolation chamber with President Nixon talking to the three astronauts through a window. So from left to right there, you see Neil Armstrong, Michael Collins, and Buzz Aldrin. Well, of course, upon returning to Earth, the three of them were greeted as heroes. There were numerous ticker tape parades thrown in Chicago and New York City. This particular image comes from a ticker tape parade in New York City. One of the more famous events happened on August 13th, 1969. So just a couple weeks after they returned to Earth, there was a party thrown at the Century Plaza Hotel in Los Angeles. This was a party thrown for the astronauts by President Nixon, and it was considered to be the biggest social event of the year. So we see the three astronauts, Neil Armstrong, Michael Collins, Buzz Aldrin with their wives. We see Richard Nixon there with his wife. And as I said, this was the biggest party of the year. The party went on to the wee hours of the morning. There was lots of drinking during this. But one of the more famous events that happened during this party is that late in the party, someone, and it's believed to be one of the astronauts, shouted out to the whole crowd, "Here's to the Apollo program. It's all over." And you might wonder, what did they mean by that? What did they mean by "here's to the Apollo program, it's all over"? The problem was that Kennedy never said anything about a second or a third landing on the surface of the moon, let alone a program where we would continue to explore the moon after this first exploration. Some people said that after Charles Lindbergh had crossed the Atlantic for the first time, you wouldn't ask Lindbergh to fly the Atlantic again, so why go back to the moon? Apollo 11 accomplished what Kennedy had set out to do, land on the moon before the decade was out. So it raised the question, why go back again? Why continue the lunar exploration? And in fact, I would argue that this is a large part of the reason why the Apollo missions to the moon were discontinued. So much of the Apollo missions were wrapped up in Kennedy's goal of safely landing a man on the moon and returning him safely to Earth. In fact, the reason that there was more than Apollo 11 planned was this thought that a landing on the moon was so difficult that the first missions might end in failure. So if Apollo 11 was a failure, they had Apollo 12. If that was a failure, there was 13 and 14. They didn't know how many missions it would take to land on the surface of the moon and be successful. So they initially planned a number of missions all the way up to Apollo 20. But we'll find out that thanks to the Vietnam War and the tremendous budget pressures that the United States government was under, and the lack of support for the Apollo missions after Apollo 11, the Apollo missions soon got canceled. Apollo 20 was lost, and then Apollos 19 and 18. NASA was able to continue through Apollo 17, but after that, the missions to the moon were over. Humanity's first exploration to another world finally came to an end in December of 1972. And since December of 1972, we have not been back to the surface of the moon. Now, the Apollo 11 landing site has since been photographed. This is a picture taken by the Lunar Reconnaissance Orbiter on March 7th of 2012 of the Apollo 11 landing site. So what we see is the descent stage, the lunar module descent stage, sitting on the surface down there. We see early in the mission, Neil Armstrong walked out and deployed a camera that looked back at the lunar module. You can actually see the track that he took and walked back. You'll notice that the places where they disturbed the soil, disturbed the regolith, are a little bit darker. Where Buzz Aldrin and Neil Armstrong went out and deployed the passive seismic experiment and the lunar laser ranging retroreflector. Those are on the surface right there with a discarded cover. And then you can actually see the footprints that they took, that Neil Armstrong took as he wandered over to the nearby Little West crater. I showed you the photographs of him standing on the rim looking into this crater about 100 feet across right there and then walking back. You'll notice that in this image the flag is not visible, and that's because as the ascent module took off from the surface, Buzz Aldrin noticed that the exhaust from the ascent module blew the flag over. You can see lots of little specks on the surface here, which are specks of debris that were blown out from this. You might wonder, what did we learn from going to the surface of the moon? What did we learn in this first mission? It's no exaggeration to say that the rocks that were brought back by the Apollo missions, and Apollo 11 especially because they were the first samples, that those samples absolutely revolutionized our view of the moon, the origin of the moon, and the origin of our solar system. In fact, the Apollo 11 mission brought back about 50 rocks altogether and a total of about 22.5 kilograms of samples, about 47.5 pounds from the surface of the moon. Most of the lunar samples that were returned to us are volcanic rocks. This is a basalt. Basalt is a very common type of lava that we find here on the surface of the Earth. And it's not surprising, having landed on the Sea of Tranquility, which scientists had suspected was an ancient giant lava flow, that most of the rocks returned would be these types of basaltic rocks, these lava rocks. About half of them were these basaltic rocks. Another half were breccias, crushed and broken rocks that were glued together by the tremendous forces of impact of other rocks striking the surface of the moon. One of my favorite stories about the lunar rocks is just thinking about this one right here. This is lunar sample 10017. So lunar sample 10017 happened to be the largest rock that the Apollo 11 astronauts brought back from the moon. And so think about the history of this rock. It formed from molten lava about 3.65 billion years ago. And that's about the age of the oldest rocks that we find on the surface of the Earth. An impact broke it off its parent bedrock and threw it onto the surface about 500 million years ago. And Then it was nudged and flipped a few more times by impacts, and finally, about 3 million years ago, it came to rest on the surface. And at that time, the primate line in Africa began to show humanoid qualities for the first time. And 3 million times after this rock came to its final rest, a remote descendant of that first primate line, dressed in a spacesuit, landed on the moon, picked up rock 10017, and brought it back to Earth. That was humanity's first exploration of the solar system. Please join me in our next lecture, Lecture 2, where we will begin the study of spaceflight by talking about the laws of motion and how they apply to spacecraft. I'll see you then.